Welcome to the Consulting Specifying Engineer Webcast, Fire and Life Safety System Design, sponsored by Edwards. I'm your moderator, Amara Rozgas, with Consulting Specifying Engineer and CFE Media and Technology. For a seamless hour of education, here are some tips. If you're having trouble with your slides or the sound, refresh your browser or click the Refresh Media button directly under the presenter's photo. You can control the volume settings by adjusting the volume on your own computer. If you're having technical problems, please click on the question mark at the top right corner of your screen to bring up a list of system checks to try before contacting an online technician. But if you do need help, please type a message into the Ask a Question box and someone will respond in the Answered Questions box. To download the presentation slides, use Event Resources on the left side of your screen. Type a question for the presenters in the Ask a Question box on the left side of your screen. You may ask questions at any time during the presentation. The Q&A portion will start in about 45 minutes. This webcast is being recorded and you'll receive an email with the link to the archive in about a week. If you're interested in earning one AIA CES approved learning unit and one AIA CES approved health, safety, and welfare unit for this event, you need to pass a 10-question exam. To take the learning unit exam and to download your AIA CES certificate, click on the Learning Unit Exam tab at the option at the top of your screen. The exam will open in a new browser window, so if you want to take the exam after we're all done, I suggest you open a new tab right now because the link will break when the webcast signs off. In keeping with the American Institute of Architects Continuing Education System Policy, please take some time to read the quality assurance slide. Thank you. Here's a list of the learning objectives. We'll touch on these in today's presentation. Please note that any red underlined text that you see is a hyperlink to a reference or resource to guide you to more information. Next, we'll hear from this session's sponsor. At the conclusion of the commercial, you may experience a few seconds of silence to make up for varied internet speeds. Please stay tuned after the video for today's presentation.
The worst thing that can happen is people don't believe their smoke detectors when they alarm. We've all had it happen where we're burning toast or we burn bacon and the detectors go off, they're making a lot of noise, and people get annoyed by that.
Hamburgers are put into the broiler, broiler's turned on high heat, produces smoke that our detectors must not alarm to. Then a second part of the test is they actually ignite a piece of polyurethane foam that then produces real smoke, not nuisance smoke, where our detectors must then alarm before a certain level.
The biggest goal is that people get notified that there's a fire in their home with enough time to evacuate, get out, call for help. So it's extremely important that when the detectors alarm, people know it's a real fire.
All right, let me introduce today's speakers. We'll be hearing from two of the fire protection industry's best and brightest. Raymond Grill has served as the president of the SFPE and as a trustee of the Board of Trustees on the Fire Protection Research Foundation. Ray was a member and chair of NFPA 72 Technical Committee on Notification Appliances and a member of the NFPA Technical Correlating Committee for Automatic Sprinkler Systems. Ray served as the principal investigator for 2 contracts with NIST regarding the World Trade Center investigation. Joshua Green has a bachelor's and master's degree, both from Worcester Polytechnic Institute. His experience includes performance-based design, building and fire code consulting, fire suppression, and fire alarm system design, and smoke control system analyses. Josh specializes in the practical application of fire protection principles in support of unique designs. Both Ray and Josh are members of the Consulting Specifying Engineer Editorial Advisory Board. It's my pleasure to work with both of them. All right, Ray, you are live now. Let's get going.
Well, thank you, Amara. That's a very nice introduction. It's always a pleasure to participate in these events. So without further ado, let's talk about what drives fire protection system requirements. So when we talk about when a system is required, whether it's fire alarm or suppression, or what type of devices are required in a building, those requirements come from building and fire codes. So if you're dealing with the International Building Code or International Fire Code, those documents have requirements for fire suppression and fire alarm requirements, as well as NFPA 101 and NFPA 1. There may be other occupancy-specific standards that could drive a requirement for a specific type of fire protection system. There also may be insurance or risk management goals that may drive requirements for fire protection systems. Now, once a requirement has been established, then we go to installation standards for how those systems should be installed. So the two that are very prominent, NFPA 72 is the fire alarm code, NFPA 13, the sprinkler standard. These documents provide the how-to when it comes to system design and installation. Right? These documents do not require systems. So sometimes I'll hear someone say, well, does NFPA 72 require smoke detectors, or does NFPA 13 require sprinklers? These documents are actually telling you how to design them and how to install them when a building or fire code otherwise requires them. Okay. So let's talk about some of the drivers for when suppression systems and fire sprinkler systems in particular are required. So most often these requirements are occupancy or hazard driven. So in the building and fire codes and NFPA 101 and IBC, we have assembly occupancies that are over 100 occupants or 5,000 square feet are required to have fire sprinkler systems. We have educational occupancies that are over 12,000 square feet or having over 300 occupants above or below the level of exit discharge. Okay, so when we talk about the level of exit discharge, that's typically your grade level, where people leave the building at grade level to exit. So if you have occupant loads that exceed 300, either above that level or below that level, you would have a requirement for sprinklers. Factories have requirements for sprinklers once they reach a square footage of 12,000 square feet, or the occupancy is located more than 3 stories above the grade level. Now, woodworking is a specific hazard that actually is required to have sprinklers within that occupancy once it exceeds 2,500 square feet. Now, there are also some other factors that may drive sprinkler systems. Actually, I just skipped over a slide. So hazardous occupancies are an occupancy that also has requirements for sprinklers regardless of the area. So hazardous occupancies, Group H, are defined by the building code, usually by the quantities of hazardous material. So there are exempt quantities that would then allow that occupancy to be treated as a different occupancy than the Group H. But once you exceed the minimum exempt quantities, you would be kicked into a Group H occupancy. And regardless of the square footage, you would need to provide sprinkler protection. Institutional occupancies, healthcare, detention centers, there are only limited exceptions where sprinklers are not required in those types of occupancies. As you can imagine, within healthcare occupancies or detention occupancies, the occupants do not have control over their ability to self-evacuate typically. So we're doing a defend-in-place type strategy, which requires us to suppress and control fires when they occur. Now, mercantile occupancies, retail, those types of occupancies are typically required to be sprinkled if you're over 12,000 square feet. And again, there is a special requirement for occupancies that contain upholstered furniture manufacturing or sales. That's considered to be a higher hazard. There's a lot of foam plastic in the construction and production of upholstered furniture. And when those occupancies are in excess of 5,000 square feet, they'd be required to be sprinkled. Now, high-rise buildings are also required to be sprinkled. That's been a requirement in the code since the mid-'80s. There used to be a compartmentation option, so you will still find existing high-rise buildings that are not sprinkled, but those have been built prior to the requirement. Now, as I was starting to mention, there's also some other conditions that might drive fire sprinklers. One of those is stories without openings, or if you have basement levels in a building that are not open to the outside. So those types of areas create problems and challenges from a firefighting access perspective, and that's what basically drives the requirement for sprinklers in those areas. Buildings over 55 feet with more than 30 occupants. So if you have again, that's an access issue for fire service, right? If you get buildings that are taller, 55 feet is not high rise. Typically 75 feet to the top occupied floor is what defines a high rise building. So you have mid-rise buildings that may require sprinklers regardless of other occupancy triggers. We also have hazards such as ducts conveying hazardous materials, so whether that be combustible dust or laboratory exhaust fumes, things of that nature, process exhaust, those ducts may require sprinkler protection. And we also have a requirement for rubbish and linen chutes to be sprinkler protected at various intervals within the chute. Now, the fire alarm system drivers are actually a little different than sprinklers, right? So they don't mesh up, right? So, we oftentimes hear people say, well, sprinklers aren't necessarily life safety. Well, in a lot of cases they are. In most occupancies, particularly if you have a light hazard, with 13 we consider light hazards, so office spaces, things of that nature. Those are light hazard. Residential quick response sprinklers are required. And there has been quite a bit of research that has been done by NIST after the Station nightclub fire that actually showed that sprinklers in that venue would have maintained tenability within that space, and that was even utilizing standard response. So now fire alarm generally is being provided to initiate evacuation or relocation, right? It's also, so we want to notify the occupants that they need to be evacuating or relocating because there might be an incident occurring. Now, the activation of the fire alarm system, may be by manual activation or maybe by automatic activation, such as a alarm initiating device like water flow or smoke detection or heat detection or some other mechanism, right? Now, in assembly occupancies where we are over 300 people at a grade level or more than 100 people above or below the level of exit discharge, we do have a requirement for fire alarm. So we might have a sprinkler requirement, and you could actually have a sprinkler requirement in the building without a fire alarm requirement. So that does occur. Now, typically when we are having a sprinkler system installed in the building codes would require that system to be monitored for activation. And it's usually required, the IBC would require either central, remote, or a proprietary supervising station monitor those systems. But if we have a fire alarm requirement, that sprinkler system water flow activation would also notify the occupants. Now you can see with assembly occupancies where we have an occupant load of greater than 1,000 people, we would have an emergency voice alarm system. So, when the code says an alarm system, it's not necessarily requiring voice. It could be requiring just sounders and strobes, right? When we have a voice alarm system, we're required to be able to provide a message, a voice message. And we also would be providing visual devices or strobes to notify hearing impaired occupants. Now, the one thing also that I wanted to mention early on is that, almost all of the occupancies, the manual activation utilizing manual fire alarm boxes is an option when the building is fully sprinkler protected. It is not, there's exceptions in the IBC as well as NFPA 101 to eliminate all but one manual fire alarm box. And one manual fire alarm box is required, and that's typically located in a staffed location. In a hotel, we would typically place that at the front desk. In a, unstaffed, where you don't have a 24-hour staffed location, it's typically located somewhere near the control equipment or annunciator panel. And the intent of that device is to be able to activate a whole building alarm should something be amiss, or also to notify first responders off site. Okay, so let's move on. Ambulatory care facilities, okay, automatic smoke detection or sprinklers with water flow is what is required to drive the fire alarm system in that building, that type of occupancy. Educational occupancies, again, we have manual with exceptions if other detection methods are provided. So if you have water flow or smoke detection, you might have smoke detection as a risk management tool. You can forego the general application of manual fire alarm boxes. But there is a requirement that's come into the code in the last few cycles for emergency voice alarm communication. So prior to a few cycles ago, you could use sounders, but new construction now is requiring emergency voice. So factory and industrial occupancies that are 2 or more stories or greater than 500 people on any floor above or below the level of exit discharge would require a fire alarm system. So, you could have a single-story industrial facility that doesn't require a fire alarm system. It may actually be sprinkled, but you would not necessarily require occupant notification. Now, it's oftentimes provided, but from a code basis, it would not be required. Hazardous occupancies, Group H. So Group H is one occupancy that requires manual activation and automatic. Okay, so manual pull boxes are required in Group H occupancies. We have smoke detection required if toxic gases are being utilized in that facility. Now, I occupancies, which would be institutional, healthcare, detention, we have manual and automatic smoke detection required in those occupancies as well. Now, the one thing about, there are exceptions in the code as to where those devices are required to be located. So we don't generally, the detention center, you're not going to put manual fire alarm boxes throughout the housing areas, for instance. Those are going to be in a controlled location for staff utilization. We're also able to use the concept of private mode signaling in I occupancy. So what that is talking about is the ability to notify the staff members that are trained to take action. So for instance, in an ICU or emergency or a surgery suite, you may not want the audible notification appliances to just start blaring in those locations. The patients can't do anything about it, right? So typically nurses' stations would be provided with notification, and you might use visual notification in a surgery suite as an indication of the emergency. Mercantile occupancies, you can see a pretty high threshold for when a fire alarm system is required, greater than 500 people or greater than 100 on any floor above or below the lowest level of exit discharge. And this is one of those occupancies, again, where you can use either, or you're not required to have the manual pull boxes if you have water flow indication. Okay. Residential occupancy. So there are some differences between apartments and hotels. So apartments being a non-transient occupancy and hotels being transient occupancies. Now, sometimes there's a gray area between the two, We're seeing some very large apartment buildings that are getting temporary hotel uses within them. So there has to be some modifications to the base building fire alarm to accommodate those uses. But one of the biggest differences is that within a transient residential, smoke detection is required within the corridors of those occupancies, whereas in a apartment building, their corridor smoke detection is not required. So in a high-rise building or a multi-story building where you have elevators, you're going to have at least one smoke detector in the elevator lobby. That's usually adjacent to the corridor, but otherwise the corridor itself is not required to be protected. And then we have high-rise buildings. So high-rise buildings, regardless of occupancy, are required to have emergency voice alarm communications. And high-rise buildings are also getting in-building two-way radio enhancement with two-way hardwired firefighters' phones. And, that's something that, believe it or not, there are still some jurisdictions that require two-way hardwired firefighters' phones and do not recognize two-way radio enhancement. They're far and few between now, but when you're developing these types of designs, it's important to interact with the authority having jurisdiction to verify what their local criteria is as well. Now, we also have some special hazards in the fire alarm area. So battery rooms are requiring smoke detection. Capacitor energy storage systems. These are, systems that we're starting to see more of. These might be UPSs. They might be larger battery storage to actually power processes in buildings. And then we also have specific requirements for what's known as fire service access elevator lobbies. Now, those are required in buildings that have floors that are over 120 feet above the lowest level of fire department vehicle access. They're hardened shafts. There's a whole slurry of requirements in the building code on these. But an additional requirement is that heat sensors be provided in the lobby that provide various, that identify the ranges and report back to the control panel in the fire command center. The last thing that might drive fire alarm systems is when we have other features in the building that require a fire alarm system to control them. So smoke control is a good one, right? We might have a three-story building with a atrium that requires a smoke control system. So generally we would have a fire alarm system to activate that smoke control system. So the building otherwise may not have a requirement, but the design feature could drive that requirement. We do have HVAC control and shutdown requirements depending on the size of the systems that are present, right? So that could be driven by a fire alarm system, or it could be direct connected to the panels as well if you don't otherwise have a fire alarm system. We also have elevator recall. So every elevator that extends more than one story now is required to have a recall. So if you do put a panel in just for recall, NFPA 72 would classify that panel as a dedicated fire alarm panel, and additional fire alarm devices would not be required. Yeah, we also might have things like door release service where, say in an industrial facility, we have firewalls or fire-rated compartments for some reason. We might have doors on hold opens to facilitate flow of product and whatnot. That might be a case where we would put a fire alarm system in to control the release of those doors. Okay, with that, I'm going to pass it on to Josh.
Thanks, Ray. Okay, so now we have a fairly good understanding of where some of our requirements come from for some fire suppression systems, fire alarm systems, prescriptive requirements, dealing with hazards and that type of thing. Let's take a little bit of a deeper dive into fire suppression systems in general. Sprinkler systems usually are the ones that everyone thinks of when we're dealing with fire suppression, and they're definitely the most codified and the most used. But it's important to have a better understanding of not just how a sprinkler system works, but how a fire suppression system works and how to pick the correct one for the application while still staying code compliant, obviously. So from an overall perspective, what are we trying to achieve with fire suppression systems? What are the objectives? In general, there are two. The first one is occupant safety. This is paramount. The most critical objective for a fire suppression system is to provide occupant safety first. And that means controlling the fire. A lot of times there's a misnomer or a misconception that fire suppression systems always suppress a fire and extinguish it. That's not necessarily the case, nor is that necessarily the proper design application for all the different types of hazards that we may encounter. Controlling the fire is the most important thing. You know, keeping it to a certain area, keeping it contained so that it doesn't spread to other areas and start to impact occupants or even the property further away from the facility or from the fire source. From an occupant safety standpoint, what we're trying to do is provide some time for occupants to evacuate, time for the detection system or the suppression system to activate and set off notification and get occupants moving to a safe area. We're also trying to provide time for the fire department to respond to that event, give them time to set up and get into the facility and start their own application of water or whatever suppression they may have for the application. But we're always trying to provide time first. We're trying to control the fire first. The second objective is property protection. Obviously, this is very important to everyone as well. Occupant safety always comes first, but property protection is very important. You want to, again, try to limit that fire size as best as you can so that it doesn't migrate to other areas of your building and get to the point where it can't easily be suppressed either by a fire suppression system or extinguished by the fire department. Fire suppression, which is something that many fire suppression systems actually do, is very important for property protection because, again, you're trying to, catch that fire early, knock it down, and then, if you can, suppress it. Some fire suppression systems are specifically there to control the fire. Other fire suppression systems are actually there as a suppression system. They're intended to extinguish the fire. So what are some of the mechanisms by which fire suppression systems operate? And remember, from a fire suppression system standpoint, we're not just talking about sprinklers. There are other suppression systems out there that are appropriate given the hazard that we're looking at. We'll talk about that a little bit more. But here are some of the suppression mechanisms that may occur depending on the type of system that you're using. Cooling. Obviously, cooling the fire is extremely important. If you know your basic combustion science at all, and I wish I would have put a diagram up here on the slide for you, the concept of the fire triangle has been around for forever. And basically, the triangle is three items that are required for combustion. The first is oxygen, the second is fuel, and the third is heat. More recently, we've kind of graduated from the fire triangle onto the fire tetrahedron, which is a four-sided item, and that adds a chemical reaction to the equation as well, which is required to sustain burning. So oxygen, fuel, and heat are necessary for combustion to occur. A chemical reaction is necessary to keep a fire sustained and burning. So what we're trying to do with these suppression mechanisms is take away at least one of those items. So from a cooling perspective, what we're trying to do is reduce the heat. We're taking the heat away from the fire, giving it less of a chance to preheat other areas and ignite other areas away from the original fire source. Water-based systems are very good for cooling. Foam-based systems are also use the cooling suppression mechanism quite often. The next mechanism is energy absorption. This is basically taking energy away from the fire, again, mostly to reduce the heat and take that portion of the fire triangle away. Again, water-based systems are very good for energy absorption. They cool and they absorb energy at the same time with the way that they work. Dry chemical suppression agents actually are very, very good at absorbing energy too, and that is one of their main mechanisms for fire suppression. Flammable liquid dilution is a very specific type of suppression mechanism. It's only really there for water-based systems and really only works on water-soluble liquids where the flammable liquid and the water can interact and dilute the whole thing. Insoluble flammable liquids obviously don't work from a dilution standpoint. The water usually drops to the bottom, and the insoluble liquid will stay on top and continue burning because it is still able to get to oxygen. Oxygen displacement, dilution reduction, I put these all together. Just about every suppression system works to this in some way. Water-based systems do this via steam generation. As the water comes out of a sprinkler or a water mist system and interacts with the fire plume, it creates steam. And that steam actually displaces oxygen much more than you would expect. Carbon dioxide systems are completely based off of displacing oxygen to the point where there is not enough oxygen in the space to actually support combustion. Similarly, inert gases work in that same way, reducing the oxygen below the level at which a fire can be sustained. Clean agents, even foams to a certain extent, work to displace oxygen or dilute oxygen. And finally, wet chemical systems, such as you might find on kitchen suppression systems most often, are there to reduce oxygen or displace the oxygen so that the burning surface, which is typically some sort of a cooking fuel or cooking oil, can't get to the oxygen. It covers it so that the oxygen can't intermix with where the fire source is. And the final mechanism is actually a chemical mechanism, and this is specific to just a few different types of agents. Dry chemicals, again, actually use a chemical mechanism as part of their suppression. They interact with a fire. Halocarbon clean agents and aerosols, this only goes for certain clean agents. They actually have chemical bonding within them where they will take what are called free radicals out of a fire, bond with them, and in so doing take away oxygen and other things from the combustion process and stop the chemical reaction that's necessary to maintain. Halon, which isn't used anymore but was a fantastic suppression agent used this type of chemical mechanism, was called free radical scavenging, to take away radicals that would stop, that bond with radicals so that the fire chemical reaction couldn't continue. Okay, let's talk about suppression types for a little bit. I would assume that most that are on this understand the sprinkler system types, so I'll roll through them pretty quickly, but there are typically four. They are all found in NFPA 13, which is the automatic sprinkler standard. The first system is a wet system. We'll talk about it in a moment. The dry system, what is called a pre-action sprinkler system, and finally a deluge system. So wet sprinkler systems are the most typical that you'll find in commercial buildings, and if you're lucky enough to have one in your residential building, in residential buildings as well. This is a simple system. The branch piping and all the piping for the system are filled with water normally. Upon a sprinkler activation, the discharge of water is immediate because it is already sitting in the pipe where the sprinkler is, and water flows only from sprinklers that have activated. This is, my wife knows I get bent out of shape a lot when we're watching a movie and something will happen and a sprinkler will activate and all of a sudden the entire room dumps water. That is not a typical sprinkler system. Sprinkler systems discharge based off of an actual single sprinkler activating at a time. So it's not a complete dump. You don't activate a sprinkler and the whole room gets flooded with water. That's a Hollywood thing, and I tend to get a little bent out of shape when I'm watching that in a movie and see it happen. But the intent is that the sprinkler is supposed to activate, drop water onto the fire, cool, and use the other suppression mechanisms at its disposal. And if additional sprinklers are needed because the heat in the room is still high enough, those additional sprinklers will go off one by one based off of that heat. We'll talk about a system in a second where you actually do get water flowing out of all the sprinklers at the same time, but it is a specific type of system. Wet sprinkler systems can be designed for control or suppression. Control mode sprinklers are typical types of sprinklers used in protection of storage occupancies. Many of you may know ESFR, early suppression fast response. These are specific sprinklers designed to actually extinguish or suppress a very high damaging fire quickly and actually suppress it instead of just controlling it. So you can design for one or the other, and the application really depends on what type of hazard you are dealing with and what you're trying to achieve with the sprinkler system. Dry sprinkler systems are typically used when you can encounter freezing temperatures in the area where your system is being installed. NFPA 13 sets the temperature rating at 40 degrees Fahrenheit, so if you expect environmental conditions in the area where the sprinkler system is located to be below 40 degrees Fahrenheit, a dry system is what you want. You don't want a wet system where you have the possibility of freezing piping. Dry sprinkler systems are typically used in exterior areas, open parking garages, things like that, where the temperature can't be maintained. Obviously, this doesn't go for those areas of the country or the world where temperatures never get below 40 degrees Fahrenheit. But on the East Coast of the United States and Canada and other areas, further north, we definitely get temperatures below 40, and you'll see a lot of dry sprinkler systems in canopies and garages and things like that. Refrigerators and freezer rooms or refrigerator and freezer buildings also get dry sprinkler systems quite often. Dry systems are basically, instead of having water in the actual system piping where the sprinklers are, you have pressurized air, or what's happening more often to combat corrosion concerns is filling that piping with nitrogen instead of air. The water is contained at a dry pipe valve near the system riser. That dry pipe valve is located in a room that is heated so that you don't get freezing at the valve itself. Once the sprinkler activates in a dry system, the air or nitrogen is dropped out where that sprinkler activates. The pressure drops and activates the valve. Water is released from the valve and flows through the piping and discharges through whichever sprinklers are activated. Again, similar to the wet system, only activated sprinklers will discharge water. It's not intended to be a system that discharges all water through all sprinklers at the same time. Given that the water is held back at the dry pipe valve instead of in the sprinkler piping overhead, suppression from a dry system is obviously delayed when compared to a wet system, so something to consider. Pre-action sprinkler systems are dry systems with an additional detection mechanism, and these are primarily used in areas where it's important to confirm that a fire event is actually occurring before you apply water to the area. You'll see the pre-action systems in areas that are protecting high-value storage items. You'll see them in data rooms where the application of water really is dependent on making sure that there's actually a fire occurring. Obviously, with wet systems and dry systems, if someone mechanically damages a sprinkler or something like that and accidentally activates it, you will get water flowing out. In a pre-action system, if that sprinkler is damaged or activated, you won't necessarily get water applying until the detection mechanism also occurs. Similar to a dry system, pre-action sprinkler system piping is typically pressurized with either air or nitrogen, and the water, similar to the dry system, is contained back at the pre-action valve, so that the system piping overhead with the sprinklers does not have any water in it. There are several different types of pre-action sprinkler systems. There's a non-interlock, which I personally have never seen anyone use, which basically just requires either a detector or the sprinkler to activate to release the pre-action valve and allow water into the pipe. Again, there's not a lot of fail-safe with this type of non-interlock system, so it's usually not used because it fairly well mimics a wet sprinkler system for the most part. Discharge. So this is the interlock. This is the second thing that needs to happen to confirm that a fire is occurring before water is actually discharged from the sprinkler onto a potential fire. And the double interlock system is the last one, and this is the one that's probably used the most often just because it provides the best protection against false alarm type things. And this requires a detector and a sprinkler to activate to release the valve and get water into the piping. I won't spend much time on deluge systems. These are basically just dry systems with a detection mechanism, but all of the sprinklers, instead of being closed sprinklers that have to activate one by one, all of the sprinklers in the system are open. Upon activation of the detection mechanism, the deluge system valve opens up, water flows into the piping and flows out of all the sprinkler system, all the sprinklers that are a part of that system. You'll see the deluge systems in areas like for protecting transformers. You'll see them in aircraft hangars quite often. And there are also some code areas where you can use them, including proscenium openings on a stage in lieu of an actual proscenium curtain. Other fire suppression systems that are available, carbon dioxide systems, which are typically used in unoccupied spaces because carbon dioxide does not deal well with occupants in the room. The reference standard for carbon dioxide systems is NFPA 12. Fixed water spray systems are very similar to sprinkler systems, but they used specific nozzles to spray the area of the hazard, typically used on transformers and tanks, and the intent is to cool those transformers and tanks if the fire occurs, not necessarily suppress a fire. Foam systems are used for flammable liquids quite often. That's what they're meant for. They also can be used in tank farms, exterior tank farms, to provide protection against flammable liquid spills from there. You'll see them in aircraft hangars from time to time because of the concerns with jet fuel that may be in the airplane that might get into the hangar. Dry chemical systems are good for metal fires. If you run into a metal fire hazard, dry chemical is something that you really should consider. Many of you that have been around for a while may recognize that dry chemical systems used to be used for cooking, protection of cooking equipment. However, oils have gotten better but worse, and oils now, the dry chemical systems actually can't deal with the higher temperatures that cooking oils now burn at. Wet chemical systems are now the agent of choice for protection of commercial cooking surfaces, especially fryers that use these newer oils. Water mist is a very specialized method of applying water in very small droplets and is used for a lot of different hazards. Also very good where water supply is limited because in comparison to sprinkler systems, it uses quite a bit less water. Gaseous clean agent systems, which could take the form of inert gases or halocarbons, are used for data centers, high value areas. These have specific requirements because they are based off of maintaining a concentration of the agent in the room for a certain amount of time to stop the combustion process. So they must be in contained areas. They must be in enclosed spaces. You can't use a gaseous clean agent in an open space or an open area. Aerosols have been coming on as suppression systems as well, and they're used for specialized hazards, specific enclosures and things like that. So selection considerations, and I'll run through these pretty quickly. Obviously, you should be looking at what the hazard is. And a lot of times water is great, but in certain cases, water doesn't play well with certain hazards. And you should be looking at non-water-based suppression systems for applications. The system goal, what are you trying to do? Are we trying to just control a fire, or is there actually a suppression mechanism or an extinguishment mechanism that's important for that specific goal? What's the availability of resources? It's hard to design a sprinkler system if the water supply is not there. Fire pumps and others can help, but if you're actually not getting water to the area, and I've had several applications where I just did not have water for fire suppression, you need to look at some other options just because the resources aren't there and available for you. Agent storage needs. This comes down primarily to clean agents and inert gases because they are stored in their own cylinders and they must be fairly close to the area where the system is set up. And if you are protecting a large enough room, the number of cylinders that you need to provide that protection can be fairly significant. Cost is always a consideration, something to consider, and the ability of the agent to reach a fire. Sometimes the combustible loading is shielded by equipment or something else. And again, water application may not be your best way to get the suppression to the source, and you may need to do something else. Open versus enclosed room, I talked about this a little bit as well. Certain suppression agents are good for one versus the other. Compatibility of the agent with protected items is very, very important. Electronics don't play well with water. That doesn't mean that you can't protect electronics with water, but you'll want to try to protect them with something else better, especially if they are very important for data or things like that. Pyrophorics react with water and therefore don't deal very well with water-based suppression agents. And finally, some environmental concerns. What happens after the suppression occurs and the discharge occurs? What's the impact on the environment? I'm going to put it back over to Ray, and he'll talk about mass notification.
All right, thanks, Josh. So I'm going to go through some of this stuff pretty quickly. Mass notification is something that came into the codes back in the 2007 edition. It first turned up in Annex E, the committee at the time developed this based on a request from the Air Force because they were putting in separate mass notification systems, and they realized that they had fire alarm systems in almost all their buildings. Why not use the fire alarm system to also allow for mass notification? So what is mass notification? So mass notification is a system for communicating information for emergencies other than fire, right? So it might be weather, it might be security, it might be an industrial accident. The options are pretty broad, okay? So it can be used for other communication means other than fire. So one thing about mass notification, you can incorporate all different types of systems in your mass notification program, right? So there is now a UL standard on mass notification. It's 2572. Almost all the major fire alarm manufacturers have had their emergency communication or their evac systems dual listed at this point. So their fire alarm panels are both listed for mass notification as well as fire alarm. Now, that doesn't mean that you can't also incorporate other means of communication. So you can see here, you can have your mass notification system trigger text messaging or computer pop-ups or external, what we call wide area speakers or sirens to warn people outside of buildings. You can trigger a reverse 911 system or have reader boards activate to give information to your occupants. Any communication tools that you have can be interfaced as part of a mass notification system. Now, we talked a little bit about emergency communication, voice, and when it's driven by occupancies. There's a couple of systems that I did want to mention. We have what we call area of refuge two-way communication that is required by the building codes and NFPA 101. Now, this can be very confusing because sometimes you don't, in a sprinkled building, there typically is not a requirement for an enclosed room as an area of refuge. But that doesn't make the requirement for an area of refuge two-way communication go away. In that case, the two-way communication is required from the elevator lobby to a constantly attended location, or it has to communicate to an off-site location. Okay? You also have elevator two-way communication, which is addressing when someone might be trapped in an elevator. So NFPA 72 now has criteria for these types of communication means as well, which is why I wanted to bring that up. I'm going to skip, mass notification, when's it required? So the Department of Defense is the only organization that actually, at this point, mandates a mass notification system, and they have a standard in the UFCs. It's DOD UFC 4021-01, which provides the design guidelines for mass notification systems. Now, the General Service Administration in PBS P100 does include requirements for the fire alarm system to provide enhanced communication, but it doesn't go as far as mandating a mass notification system at this point. Now, there are other requirements that are coming into the codes, into NFPA 101, as well as the IBC. So here's some examples. In the 2018 edition of NFPA 101, there is a requirement that a risk analysis be performed to determine whether a mass notification system is required for new high-rise buildings when over 420 feet, or when there's more than 5,000 occupants in a high-rise building. New assembly occupancies with 500 or more occupants are required to be, a risk analysis is required to be performed to determine whether it's required. New educational occupancies, K through 12 in college and university dormitories, new mall structures, and then business occupancies with a classroom and owned or rented by a university or college, okay? So a risk analysis is required under 101 for those types of occupancies. Now, in the 2018 IBC, there's also some requirements for risk analysis. So again, universities and college campuses with a cumulative occupant load exceeding 1,000 are required to have a risk analysis. Okay, that's in the IBC now. All right, so why is a risk analysis required? So, you know, I've served on the Emergency Communications Committee. Actually, I co-chaired the task group that put mass notification into the annex, and I've been involved with it ever since. But one of the things that the committee recognized early is that every site is not the same. It's not like, you know, we know how fire spreads, we know how it grows, and that, you know, you can put that fire in, you know, in Cincinnati, or you can put it in Chicago, or you can put it in a suburb of wherever, and that fire is going to grow the same way. But when it comes to mass notification, we have different hazards depending on the site-specific conditions. Like I said earlier, it could be weather-related. You know, Hurricane Alley, or a Tornado Alley, rather, or hurricane areas, or, you know, we could have weather-related things, or we could have industrial hazards that might justify having mass notification system. So chemical plants, for instance, oftentimes will have wide area signaling to neighboring communities. If they have an accidental release, they'll automatically notify occupants that would be in the plume, or in the direction of the plume as it travels to warn occupants. So that's actually a mass notification system. So the committee realized that prescriptive requirements really couldn't address all the situations. So what's a risk analysis intended to do? I mean, it's a process that is thought through to characterize the likelihood, vulnerability, magnitude of incidents associated with natural, technological, man-made disasters and other emergencies that address scenarios of concern. Okay, so the one thing that, you know, 72 does not intend is, the committee does not intend a thesis be developed to design a mass notification system. One of the things that there's been language added in the last cycle of 72 that recognizes that there might be an emergency response plan in place that addresses the hazards. So some level of risk analysis has been performed. The mass notification system can then be designed to address the communication needs of that emergency response plan. Okay, we're starting to run out of time here. I know we went a little fast on some of these, but want to leave some time for questions and answers. So I think at this point, I think I've hit the high points of risk analysis. There's a lot of things that have to be considered. All of this information is located. There's quite a bit of annex material in 72 as a reference. But the point I want to make is that you don't need to do a thesis to develop these types of systems. So with that, I'm going to pass it over to Amara to handle questions. Thank you.
Excellent. Thank you, gentlemen. And it is now time for the question and answer portion. Please type your questions in the Ask a Question box on your screen and type the presenter's name before your question so that I know who I should ask. To download these presentation slides, please use the Event Resources tab on the left side of the screen. And don't forget, you can earn continuing education To take the exam, use the Learning Unit Exam tab. You have to get 8 out of 10 correct to pass the exam. You'll be able to download your certificate immediately upon completion. All right, gentlemen, let's take a couple of questions here. Let's see, Josh, this first one goes to you. If you could please explain 2 different design approaches. First, the prescriptive approach, and second, the performance approach. Can you talk about that a little, Josh?
Of course. So prescriptive is typically the simpler method of a design approach. What it does is it bases the concept and the design off of existing requirements in the building code and or the NFPA standards that are referenced. Understanding that prescriptive building codes, the model building codes, NFPA 101, NFPA 1, the International Building Code, et cetera, are intended to cover a large amount of different applications, different occupancies, and so on. They tend to be a bit generalized and have to be in order to not be a 1,000-page document to try to deal with everything that might be encountered. So the prescriptive requirements of the prescriptive design is one that's done to the building code and to the design standards without any divergence to evaluate hazards. Performance designs, on the other hand, are intended to actually evaluate a specific hazard for a specific building or area that you're trying to protect. Ray talked about risk analysis for mass notification. That concept rings true. That's a performance analysis. It's evaluating the actual risks that are involved, what's going to be encountered, or what's anticipated, and designing to that. You need to be careful with performance designs because code officials and others that are reviewing these designs need to understand why you're choosing to do things, and they have to also agree with that. Whereas the prescriptive design approaches are almost always accepted because they're codified. So, performance has its place and prescriptive has its place. Choosing the correct one is part of a designer's responsibility. But be sure that whatever you're doing, you're picking the correct application for the hazard.
Excellent. Thank you for that clarification. Ray, the next question goes to you, and we've got about 1.5 minutes to 2 minutes to answer this one. It's kind of specific. So parking garages, Group S, do not require a fire alarm system. However, if the garage has an elevator with recall, is a fire alarm system required, or is it just the recall system required?
Well, that's a good question. And so this would be a standalone parking structure that typically does not need fire alarm, but elevator recall is required. As I mentioned, the elevator codes require recall for an elevator that extends more than 1 story. So the fire alarm panel would typically be provided for detection. Now, if it's an outside environment, the code allows you to put heat detectors in those lobbies for recall in lieu of smoke detectors, because the smoke detectors might not be, they'd be typically outside their range humidity levels and temperatures if you're in most climates. But that panel is what NFPA 72 calls a dedicated fire alarm panel. It's specifically defined in 72, and additional fire alarm devices are not required. It is just there to provide the elevator recall function.
All right. Thanks, Ray. I would like to close by thanking these brilliant subject matter experts, Josh Green and Ray Grill, for sharing their wide-ranging knowledge and for providing valuable examples of fire and life safety system design. And I'd also like to extend a special thank you to sponsor Edwards for supporting this education session. Now that the technical portion of this webcast is done, we want your feedback. A short survey will pop up on your screen as soon as this webcast ends. Please take a few seconds to complete it. We use this information to improve future education. Finally, on behalf of Consulting Specifying Engineer and CFE Media and Technology, thanks for attending this webcast. This is the end of today's event. Thank you for joining us, and we'll see you again soon. Goodbye.